In this concept video, we're going to be discussing the 6 trigonometric functions, and we'll also talk about why there are only 3 on your calculator, and also that wonderful memory aid SOHCAHTOA only has the 3 there. To do that, what I've done is I've labeled some things on these 2 triangles. So take a minute, pause the video, and then write this information down. If you'd like to, you can actually measure these sides on your paper. If you have the notes that you printed out online or that were handed to you in class. You'll notice that this side length of this triangle here, the adjacent side of the first one, is actually 4.8 centimeters. So you can verify those results. Keep in mind that these are not super precise. They're rounded to the nearest tenth. That was just what my ruler had. And so yours might be very, very close, if not exactly those as well. I've also labeled an angle here, theta, as being approximately 34 degrees. You can also measure that with a protractor. That's the actual angle itself. And then I've also written some things here in terms of theta. We've got the adjacent side, which forms part of the angle. We've got the opposite side, which does not form part of the angle. And then the hypotenuse is always opposite of the right angle, and it will be the longest side of that right triangle. This angle here is also 34 degrees, and I've labeled the opposite, the adjacent, and the hypotenuse side. You'll note from your days in geometry that these 2 triangles are similar. In other words, their sides are in the same ratio. Let's begin with discussing how many combinations where order is not considered there are if you choose 2 sides out of the 3 possible. To work these types of problems with combinations and permutations, sometimes it's easy to use a tree or a tree diagram. So let's do that over here on the right hand side. So we've got maybe a hypotenuse to choose from. The very first thing we can do, we could also choose an opposite side, and then we can choose an adjacent side. The second part of this will be then the other ones. So if you choose hypotenuse first, you could choose opposite second or even adjacent second. We're not considering replacement here. And then also you could do for opposite, you could do the hypotenuse next or the adjacent, or A. And then here you've got, let's see, hypotenuse, and then also you've got the opposite side. So if we look here, we've got, looks like 6 total possibilities, but here we say that order is not considered. So hypotenuse and opposite is going to be the same as opposite and hypotenuse. So we'll just count that once. So if we write that as a ratio, we've got opposite over hypotenuse. We're saying that's the same as hypotenuse and opposite. We've got hypotenuse adjacent. Here's adjacent hypotenuse. And let's see, we just covered that one. We've already got this one. This one we already covered. Oh, we have to do opposite and adjacent, and that will be the same here as adjacent over opposite if we don't consider the order. Turns out that there's only 3 combinations of these that are possible where order is not considered, and that's why you see 3 of them on your calculator, and that old SOHCAHTOA that your Algebra 2 teacher hopefully beat into you, that those exist as 3 because those are the only possibilities. So these right triangles in the real world are very, very useful. They're useful in mathematics, physics, science, lots of places. And so we actually give names to these 3 ratios so that we can communicate easily about them. So we say that the sine of the angle is opposite over hypotenuse. That's the SO part of SOHCAHTOA. The adjacent over hypotenuse here, we give the name cosine. So I can write that out if you want here. The past one was sine, that's the full word. And then we've got cosine here, and that's equal to the adjacent side over the hypotenuse. And then this one, opposite over adjacent, that's going to be the tangent. When we write that out, it looks just like it sounds, just tangent. If we look at how many permutations where order is considered, we have hypotenuse and opposite, and now that's going to be different than opposite and hypotenuse. So you can see we've got 1, 2, 3, 4, 5, 6 total possibilities. That's why there's only 6 total trigonometric functions. There's just no other way to arrange the sides of a right triangle if we choose 2 out of the 3 to make a ratio. So let's talk about the other ones, and we could say, I suppose the answer to this previous combination was there are 3 ways, and then this one is 6 ways. But I want to kind of segue into what we call those things. So keep in mind your 3 main trigonometric functions. Those do appear in your calculator. You'll see that sine, cosine, and tangent. And then if we look at the other ones, let's look at hypotenuse over opposite. And we call that cosecant, and the abbreviation is CSC. So I'll write that out for you. And then the other one here, we've got adjacent over hypotenuse as being cosine, so there's also hypotenuse over adjacent. And that function will be the secant. We abbreviate with 3 letters as SEC. And then the last possibility here is going to be the cotangent, which is adjacent over opposite. And that's just written kind of like it sounds like tangent does, but with a co in front. We'll talk about the whole co thing, the co-functions, in a later video. But right now what I'd like to do is, in your notes, I think that comes next, but I'd like to skip over the co-function and the reciprocal trig relationships. We're going to do those in the next video, so you look forward to that in part 2 of the concept. But I do want to slide down to the bottom of the page now. And at the bottom it says measure the sides and the angle theta for each triangle, then find each trigonometric ratio. Use centimeters and round initially to the nearest tenth, then round the ratios to the nearest thousandth. Again, if you'd like to pause and set these up on your own, I can explain where these come from actually as I go through them, but I've written them all out here. No need to bore you with me writing down all of these different things. I will tell you how I got them though. So 34 degrees here, if we bring the other triangle back in, the first triangle, triangle 1 here, that's our angle. And then if we're looking at the sine, it's the opposite side, which is 3.2, over the adjacent side, which is 4.8. You'll notice I don't have my units here. If we have centimeters on the top and centimeters on the bottom, those will cancel out anyway. Feel free to put them there if you'd like, but they're not very necessary, or not really that quite necessary for this one. All of the other trigonometric functions are set up in the same fashion. So we've got the cosecant of 34 degrees. That's just the reciprocal of the sine. The sine is opposite over hypotenuse. The cosecant is hypotenuse over opposite. All the rest of the functions are set up just like that. And then also what I've done is I've typed all these into my calculator, and I found the decimal approximation of the fraction here, and that's rounded to the nearest thousandth. It's important that you guys understand that when you set up these trigonometric ratios, you must have a right triangle, and if you know that other angle, then you actually know that what you're dealing with are similar triangles. And so I want you to see what happens when we have these 2 similar triangles that you know each one is 90 degrees and then the other angle is 34 in this case. What happens is that when you take the opposite over hypotenuse side for each one, and again we just call that the sine, so we know we're talking about opposite over hypotenuse, which, think about it, opposite over hypotenuse is kind of wordy. Sine's just easier, and if you abbreviate it as SIN, it's even easier. So on triangle 1 we've got 0.561, and on triangle 2 we've got 0.558. And remember when I was saying that my ruler is not entirely precise, at least the divisions here are to the nearest tenth of a centimeter. I'm not sure if you can see that there. So sometimes the side length landed like right in the middle of one of the tenths or closer to one side. So the thought here is if we could be as precise as we possibly could, these numbers would be exactly the same, and they're very, very close anyway. The cosecant is also very, very close. You'll notice here that we got this one right on, that if you take a look at the cosine, which is the adjacent over hypotenuse, as long as the angle remains the same and you have that right angle, then you'll wind up having the exact same value when you take the ratio of the adjacent side and the hypotenuse side. also the secant worked out as well. And then coming down here to the tangent, we've got something that's very, very close also. So one of the main ideas here is that to use these basic trig functions, I'll write this here in big letters hopefully, is you must have a right triangle to set these basic trig functions up. If you do, you're good to go, and actually your calculator can help you evaluate some of these things, and then we'll use these in some of the examples. So look forward to those, and we'll put these trigonometric ratios to use.